Hi, it's Sid here from Border Archery. um, Basically, what I'd like to try and do is I'd like to try and discuss the idea of dynamic limb mass. The mass out at this end of the limb and not at this end of the limb. Okay, so what we're talking about is this part of the limb, right, hardly moves at all, barely a millimetre. This part here moves reasonable amounts. This part here moves quite a lot. And this part here moves a lot. So the acceleration really does mess about with the bow performance in terms of if this part here weighs a lot, then bow performance will be slow. This part here is less important. This part here is less important. This part here is totally irrelevant. So how do you measure that without cutting the limb into bits? And that's where this test starts to come in. Okay, so let's have a little look. What we've been doing for non-destruct testing, base understanding, is to put a limb like a bridge, right? And you can see the mass on the limb tip. Okay. Now, if I put a weight here, you'll see that it affects the mass. But if I put the same weight back a bit, it doesn't affect it as much. Okay. So the importance of how far each part of the limb is up this end, the more important it becomes on the weight of the scale. Okay? So just to give you an example, our synthetic core here, carbon limb, this one here is measured on a medium 36 pounds, right? Comes out at 61 grams, right? Now, I'm not talking about the energy in the system, I'm just talking about the ability for the energy to come out of the system. Okay, so here is a 38 pound medium. Okay, right. I'm not doing anything wrong here, right? I'm just trying to show you that there are different masses involved in the limbs. Okay. Now, I'm also trying to show you that it's not exactly complicated science for you to check which limb, if the energy is equal, which limb will be faster. Okay, so as I say, if you put the mass there, and if you put the mass there, yeah, for the same mass, it has more importance when it's up this end. So it's a fantastic demonstrator of the dynamic mass of the limb. The one downside to this equation is that when you've got two equal limbs with different geometries, and more of the recurve is, more of the limb is recurved, then more of it is actually sitting over the top of the scale. Okay, so if I was to flatten that out, then the tip would be sitting up here, of which all this wouldn't be sat on top. Imagine if it was all recurve, it'd effectively be sitting, all of the mass of the limb would be sitting on top of the weight scale. Okay, so there's the reason why you get different bow performance from different constructions. And just because it says carbon foam doesn't mean to say they're anywhere near equal, okay, because a lot of them have got glass fibre in them. All right, so anyway, old obsolete limb, not being disrespectful, they don't make it anymore, so therefore it's fair game for observations. Right, thanks for watching.